Hello, class 12th students. Uh, we are doing the chapter 5, continuity and differentiation. So in this way, in this process, we will do today the exercise number 5.5. So this we say differentiate the functions given in exercise 1 to 11 with respect to x. See this question number 1, we have a three functions are multiplied, cos x, cos 2x, cos 3x. See, whenever the three functions are multiplied, or we have a more than three or three, we will use the logarithmic differentiations are there. We will take, say, let's say that here this is equal to y. Let's say we say this is equal to y. Okay, this is equal to y. Taking log both the sides. Taking log both sides. If you are taking log both the sides are there, then what are you getting? D log y equal to, say, what is the formula for the logs are there? I will write down here. Log AB equal to log A plus log B. You may write down this formula easily. Log A into B can be written as log A plus log B. So log y is here. I will take the log of whole function. You can say cos x, cos 2x, and this cos 3x. Okay. Now, simplify this one. You can say log y equal to log cos x plus log cos 2x plus log cos 3x. Now, if I want to differentiate with respect to x, differentiate both sides with respect to x, you are getting 1 upon y log y, not log y, 1y dy by dx equal to log cos x means 1 upon cos x. And now do the differentiation of cos x. This will comes out minus sin x plus 1 upon cos 2x multiplied by, we can say, minus sin 2x plus log 3x, 1 upon cos 3x can be multiplied by minus sin 3x. All right. Now, I will write on the next line. Simplify the things are that. You see, we are getting the sin x upon cos x. Dy by dx can be written as this y will be here, y times sin x upon cos x become the minus of tan x. Sin 2x upon cos 2x become the, you can say, the minus tan 2x. And this becomes minus tan 3x. You put the value of y equal to what? Cos x, cos 2x, cos 3x. So the dy by dx comes out cos x, cos 2x, cos 3x. If we take this whole minus sign outside, minus 1, minus, and we have multiplied by tan x plus tan 2x plus tan 3x. So this is the question. Answer of this question is that. Now let's say in this question number 2, we want to differentiate this function. So I say question number 2, I say this function equal to y. Put the y equal to this function. Okay. Now taking log both the sides. If we take the log, both the sides are there. We are getting here. We say we are taking the log of this one. I say log. Okay, log y equal to log of that part. Say log of x square will be 2 times log x. Okay. Or in general, we say log of a raised to b can be written as b log a. And so we are using these formulas here. Or also you can say log of a upon b can be written as log a minus log b. All right. Log y equal to what? Yes, we say we take the log of this one. Log x minus 1, x minus 2 divided by x minus 3, x minus 4, x minus 5. Square roots are there, so we take the power half. Okay. Now simplify this one. So log y will comes out. Half is there, taken outside, half. Now log of x minus 1 plus log of x minus 2 plus log of, not the plus sign, this is the minus sign, minus log of x minus 3 minus log of x minus 4. Okay, I want to keep it outside also. Minus of log, okay, we write down here log x minus 5 and this bracket closed. Now again we differentiate this function with respect to x. We are getting, if we differentiate with this function with respect to x, we are getting 1 upon y log y, not y, but log y, dy by dx log y differentiate dy by dx equal to half constant taken outside dy dx of log x minus 1. It comes out 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5. Bracket closed. So dy by dx can be written as the value of half y is here also. So we leave this question here because we don't want to simplify too much here. And correctly. So better I will just only put the value of dy dx y here only. So dy by dx will be equal to y times y, and you put the value of y here. If you simplify all this one, this will be much complicated functions are there. So y is here. I put the value of y 1 by 2, and you say the value of y is here. Just write down the value of y. This is under root x minus 1, x minus 2 divided by x minus 3, x minus 4, x minus 5. Okay. And this is multiplied by what? The answer 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5. This will be the answer of this question. Now, question number 3. I would like to differentiate this function log x raised to cos x. Say differentiation of this function says what? Taking the log both the side. We again put it here, this y equal to log x raised to cos x. Okay. Taking log both the sides, it becomes log y equal to cos times cos of, if you take in the log both the sides, cos x log of log x. Okay. Now log of log x, so the function is that, not a log of log x. Now taking the differentiation both the sides, we are getting 1 upon y log y. Log y, differentiation of log y is 1 upon y, and we say y is there because this is not x, so it is dy by dx. Then we take here cos x into log x. These are two functions, so we apply here the uv. Cos x is working as a u, and this log x is working as a v. So we apply the uv products are there. Cos x, differentiation of cos x will be, minus of sin x, and keep the second terms log x as it is, log x plus first term cos x u as it is. Now differentiation of second part log x, 1 upon log x into, now log x is there, is not the log, we say 1 upon x. All right. Now let me simplify this function. Y is here. There is nothing too much to do the simplification in this question. Only we have to put the value, rearrange the terms are there. Y should goes in the right hand side. So it is y, the value of y is log x raised to cos x. This multiplied by what? Minus sin x log x plus cos x divided by x log x. This is the end. Only the rearrangement of the terms are there only, and this will be the answer of this question. Question number 4. X raised to x minus 2 raised to sin x. I would like to differentiate this function. So I say, because there's two functions are there. Let's say y equal to this part. So I will write down here the y equal to this function x as a u and this function as v. So y equal to u minus v. Okay. If we differentiate both the function with respect to x, we are getting that dy by dx equal to what? Du by dx minus dv by dx. So I have to solve this question in two ways. One is u equal, find the value of first u equal to what? X raised to x. If we differentiate this function, this, because you see this is a function of function, x is a function of x. So whenever we have a function, power of function, you see the one function fx, and this is the power of another function gx. We will take the logarithmic differentiation. So take the log both the sides, log u equal to x times log x. Okay. Taking the differentiation, we are getting 1 upon u du by dx will be equal to x log x. X is the first term, this is a product. Now we use the product formula for the differentiation. X, differentiation of x, it is 1. keep the second term log as it is, plus first term as it is. Take the differentiation of log x. This comes out 1 upon x. So you can say du by dx will be equal to u times u is here, x raised to x log x plus 1. Similarly, now you see this, what is the v is there? V equal to 2 raised to sine x. This is a direct formula that dv by dx will be equal to what? 2 raised to sine x into log 2. And now we do the differentiation of this sine x, that we say cos x. Right. So what the value of dy by dx comes out? Dy by dx comes out is a sum of dy by dx x raised to x log x plus 1 plus sometimes of dy by dx, that is this part, 2 raised to sine x into log 2 into cos x. So this is the answer for this question, is this one. I hope you are enjoying. Now, question number 5. We want to do the differentiation of this function, is that x plus 3 square. This is 3 product terms are there. Our product terms 1, 2, 3. We have a 3 product terms are there. Okay. These 3 product terms, say we know the formula for only 2 product terms. That is the product formula. For now, we have to take the logarithmic differentiations are there. Means I take this one equal to y equal to this whole function. Taking log both the sides, you are getting log y equal to log of this whole part. Log of, you can say, this whole function x plus 3 square into x plus 4 cube into x plus 5 raised to 4. Okay. So now you say that log y will be equal to what? Separate these terms. You are separating, all the terms are there. You are getting first term, second term, third terms. Okay. So log x plus 3 square plus log x plus 4 cube plus log x plus 5 raised to 4. Further, you can simplify the log function before doing the differentiation. It can be written as 2 times log of x plus 3. This can be written as 3 times log of x plus 4. And now you can write down this one as 4 times log of x plus 5. Now, taking differentiation, or now we say do the differentiation with respect to x variable. Y is not the variable, so we say taking y, log y equal to 1 upon y, and since we are doing the differentiation with respect to x, so it comes out dy by dx equal to 2 times 1 upon x plus 3 plus 3 times 1 upon x plus 4 plus 4 times 1 upon x plus 5. Okay. Now if we simplify this one, or I take out here this y value of y in the right hand side, can we give the simple forms? Yes, let's see. This will equal to what? X plus 3 whole square x plus 4 cube x plus 5 raised to 4. And this is multiplied by what? 2 upon x plus 3 plus 3 upon x plus 4 plus 4 upon x plus 5. As we always try to do that, we don't want denominators. You have learned already in earlier classes. So we want to simplify this one. I can open these terms separately. So what will comes out? X plus 3 will be cancelled out. We are getting this denominator will be removed, but we have a terms 2. 1x plus 3 will cancel out. X plus 3, x plus 4 cube, x plus 5 raised to 4 plus. This x plus 4 will be cancelled out. We see right down here the 3 times x plus 3 whole square, x plus 4 cube, not cube, this now becomes the square, x plus 5 raised to 4. Now, we see that here the next one, third terms will be plus 4 times, because this is the x plus 5, so 1 x plus 5 will be cancelled out. X plus 3 square, that's the x plus 4 cube, and is x plus 5 power 4, 1 reduced cube. So this is the answer, because we don't want to write down the most thing, the denominators are there. If we can able to simplify it, we will try to simplify it. Question number 6. And again, you see this function is a sum of the two functions. Okay. And this two functions sums are there. Two functions is there. I say y equal to this function. So we write down here the y equal to here. This is a u function, and this is the second function is v. We say this is a u and this is v. And we say differentiate with respect to x. Dy by dx will give you du by dx plus dv by dx. So now, what we'll do here, I will separately do this differentiation of u and differentiation of v, and then we put up here. You see, u equal to what? U equal to x plus 1 upon x raised to x. Function, keep raised to another function. So we use the log function. We have to take the log. We have no choice, because there is a function raised to function. Taking log both the sides, you are getting log u equal to x times log of x plus 1 upon x. Now, do the differentiation with respect to x. You are getting 1 upon u du by dx equal to, I say, first function x, differentiation of x 1 into second function as it is plus first function. Now do the differentiation of second part. We see that here 1 upon x plus 1 upon x. And now you see differentiation of this x plus 1 upon x. Again, we need it here. So we see that here if we do the differentiation, and then we are getting 1 plus, not the 1 plus, 1 upon x will give the differentiation minus 1 upon x square. So 1 minus 1 upon x square, and bracket closed. Okay. Now, I would like to simplify this functions are that. So du by dx can be written as u is here, x plus 1 upon x raised to power x, right? And second thing is what we say, multiplied by the function, whole function, the function log x plus 1 upon x, log x plus 1 upon x. Okay. Now, this function you say that here can be simplified. I will try to say this x is there, this is 1 minus 1 upon x square, this is x plus 1 upon x. If we try to simplify this one, we are getting here the x square, this x is there, okay, multiplied by this one. So this x, I will take this x multiplied by this part, x minus how much comes out, let's say, plus x minus 1 upon x, okay, divided by x plus 1 upon x. This bracket closed. So here this may be simplified, but there's need of any simplification further. I think not too much is needed. But as I told you that here we don't want need the denominators are there basically. So I can simplify this one. So taking this denominator is still there. You can't remove the denominator. So keep the answer here. Now the value of u du by dx you have just find out. Now we have to find out the value of this v. V is there. Now v is here. dv by dx of this part. So v equal to what? X raised to 1 plus. So first we write down the what is the value of v. V equal to x and his power of x. In this power of x, we have a function 1 plus 1 by x. 1 plus 1 by x. So differentiate this one with respect to x. What you are getting? dv by dx, and because we can't differentiate it directly, because this is and the function is function of function. We don't know any formula, so we have to take the log both sides. Log v equal to 1 plus 1 upon x times log of x. Okay. So now this is a two functions are there. Differentiate with respect to x. 1 upon log v has given 1 upon v and dv by dx. This will comes out. Now do this differentiation of first part. 1 has given a differentiation 0 and 1 upon x will give you differentiation minus 1 upon x square. Okay. This multiplied by the function log x plus first function. And now do the differentiation of log x. This comes out 1 upon x. Right. Now, we will let me write in the value of dv by dx. So dv by dx comes out, taking this v in the right hand side with the value of v, x raised to 1 plus 1 upon x into, simplify this one. Let's say if we simplify, okay, no problem, minus log x upon x square. This x is there, plus 1 upon x multiplied by 1 plus 1 upon x. If we open this bracket or combine these terms, right? If we combine this term x square with this one, so take the x square as a, open these terms first. This x square is there, this x power is there. So I take this x square in the upper side. It becomes x raised to, with minus sign is there outside, 1 plus 1 by x minus 2 into log x. See the second terms, this x is there taken upper side, and you have multiplied with the 1 plus 1 by x. Okay, plus x times, writing here 1 plus 1 by x minus 1 into 1 plus 1 by x. So you are getting here the terms. Just we do the simplification of this term. Minus x raised to, you can say 1 by x minus 1 log x plus x raised to 1 upon x, and that is multiplied by 1 plus 1 upon x dv by dx. All right. So now in the dy by dx will be equal to what? Take the sum of these two equations. Write down in the answers that du by dx. You may also simplify this part also. Take the sum of this equation number 1 and equation number 2. Okay. This is the answer of your question. Now, see this question number 7. I would like to do the differentiation of this whole function, but this is a summation of these two functions are that. So we write down here the y equal to this function, so y equal to what? U plus v. Okay. So naturally we have to do the differentiation of the y with respect to x, both the sides. You say dy by dx equal to du by dx plus dv by dx. So I have to find out u. U equal to what? Log x raised to power x. Okay. Taking log both the sides, you are getting log u equal to x times log of log x. Okay. Take differentiation. 1 upon u du by dx will be equal to what? See here, taking the x 1 log x plus x. Now we do the differentiation of this one. 1 upon log x, and this comes out 1 upon x. So du by dx, you can say here, I will just write down here the du by dx will comes out. U is here, take the u right inside, log x raised to x multiplied by log x plus, you see this x cancel out, and we are getting only 1 upon log x. See, thing is that, as I told you in the previous question also, that we don't want the denominators terms are there. So log x in the denominators are there, can be multiplied, removed from the denominator sides are there. Yes, we can say it can be written as log x raised to minus 1. Open this terms better. Log x raised to x into log x plus, combine these two terms. We are getting log x raised to x minus 1. This is, we say du by dx. We say this equation number 1. Now, second part, x raised to log x. We have to find out this value of x raised to log x. V equal to, given to you, V is given x raised to log x. Let me check it again. It is same or different. X raised to log x. Fine. Now do the differentiation. Before differentiation, you take the log both the sides. Taking log both the sides, we are taking the log v equal to log x into log x. Okay. If we do the differentiation, we are getting here 1 upon v dv by dx will be equal to what? See, this log x and this log x are there. 2 times log x are there. So log x square. This can be written as log x whole square. So 2 times log x multiplied by 1 upon x. So implies that what the dv by dx comes out. dv by dx comes out, v is here, x raised to log x multiplied by 2 times log x divided by x. So this log, okay, this cannot be combined. So you combine the both the answers, equation number 1 and equation number 2. You are getting the answer. Let me, because this is easy terms, so I can show you also here also that dy by dx will comes out log x raised to x log x plus log x raised to x minus 1 plus 2. You see x is there, taking x upper side, x raised to log x minus 1 into log x. So you may say there is so many log x terms are there in this question. So I may combine some terms or may leave it here with no problems, because we see log x raised to x terms are there. So I can combine these two terms or maybe leave out here. Let me combine the terms better. So dy dx log x raised to x minus 1. Okay, I take common. So what we are getting? Say log x, we are taking the common. So this has a 1 log x less. So log x into log x plus 1 plus 2 times x raised to log x minus 1 into log x. So this will be the answer of your question. Okay. See, in this question, we have question number 8. We put this sine x raised to x plus sine inverse root x. So we see the y equal to this one u and this function is v. So dy by dx equal to du by dx plus dv by dx. And u equal to sine x raised to x. That will be say taking the log both the sides. Log u equal to x times log sine x. This comes out 1 upon u du dx. You see this one. Differentiation of x 1 log sin x plus x 1 sin x cos x. Okay. Then we do the differentiation of the du by dx. This will comes out this value. Now, what I am saying, it is the different color. So you will find out v is simple one. V equal to sine inverse root x. If we do the differentiation of this sine inverse root x, I say dv by dx equal to 1 upon under root 1 minus x 1 upon 2 root x. Combine these two things, we are getting the answer. So we hope that you understand well.